Let's understand polynomials and linear relationships in this video. Have you ever used a simple rule to find how much to pay or how many tiles you need as a pattern grows? Those everyday rules are often polynomials and linear relationships hiding in plain sight. An algebraic expression is a mix of numbers and variables joined by plus or minus or multiply. A term is a single part of that expression, like 2x squared or 5xy. A coefficient is the number multiplied by a variable. For example, 5 in 5x. A variable is a letter that stands for a value, like x or y. An exponent tells how many times a variable is multiplied by itself. For example, x squared means x times x. An operator shows the operation, like plus or minus. A constant is a number that does not change, like 7. When an expression uses only one variable and whole number powers, we call it a univariate polynomial. The degree of a polynomial is the highest power of the variable. For example, degree 2 for x squared plus 5x plus 1. Types are easy to remember. Constant has degree 0, linear degree 1, quadratic degree 2, cubic degree 3. Algebra helps in real life to make repeated work faster, like finding costs or areas using formulas. Here is a food market example. Each apple box has 10 apples, and each orange box has 12 oranges. If a customer buys X apple boxes and Y orange boxes and gets 5 extra fruits, the total is 10x plus 12y plus 5. This short expression shows how variables and numbers make life simple. Another example with a rope. A 24-meter rope makes a rectangle, so perimeter is 24. That gives length plus width equals 12. If width is x, then length is 12 minus x. The area is x times open bracket 12 minus x close bracket, which equals 12x minus x squared. Now let us look at linear polynomials, which are expressions of the form ax plus b with a not equal to 0. Linear polynomials become linear equations when we set them equal to something, and they give a single output for each input. A simple gym example. Registration fee 500 rupees and 100 rupees per day gives total y equals 100x plus 500. The amount increases by a constant 100 rupees for every extra day, showing constant difference. A linear pattern is a sequence where the gap between terms stays the same. Example: 1, 3, 5, 7, 9 has the same difference 2, and its general term is t sub n equals 2n minus 1. A bus fare example helps too. First 3 kilometers cost 30 rupees, and then 10 rupees more per kilometer. For 12 kilometers, the fare is 30 plus 10 times 9, which is 120 rupees. And the general rule for n kilometers becomes 30 plus 10 times open bracket n minus 3 close bracket. Linear growth means a fixed increase over equal steps. Linear decay means a fixed decrease. For example, temperature T of a liquid might be T of T equals 80 minus 2T, losing 2 degrees every minute. A linear relationship between x and y is written as y equals ax plus b, where a is slope and b is y-intercept. To find a and b, we can use two known pairs and solve, like the taxi example. 5 kilometers costs 120 and 15 kilometers costs 320. Subtracting those equations gives a equals 20 and then b equals 20. So the fare is y equals 20x plus 20. To draw y equals ax plus b, we pick 2 points that satisfy the equation and join them to make a straight line. Slope shows how steep the line is. And when b equals 0, the line passes through the origin. Positive slope makes the line go upward left to right. Negative slope makes it go downward. If a grows bigger, the line becomes steeper. If a is smaller, the line becomes flatter. Changing b shifts the line up or down without changing its steepness, and lines with same slope but different b are parallel. So, what do we learn from this? We learn that polynomials are expressions of numbers and variables, and linear ones make simple straight line rules. Linear rules help us predict, model, and solve many real problems like costs, areas, and patterns. Let us quickly remember terms, coefficients, variable, exponent, constant, degree, and the form y equals ax plus b. So today we learnt what polynomials are, how linear polynomials work, and how slope and intercept change a line. Keep exploring with small examples around you, like fares, fees, and tile patterns to spot these ideas. Learning is a step-by-step game, so stay curious and try making your own examples on paper. Thank you for listening. And if you want more simple examples and practice, do explore the lessons on EduRev gently at your own pace.